Hello students, I am again back with another important topics in chemistry, that is electrophilic addition reaction. You look at the notice, you look at the heading, electrophilic addition reaction. First of all, what is electrophile? Electrophile are electron seeking species. Electron seeking species which carries positive charge, or by means of polarization anyway some positive end is produced, such as example H plus. In case of your HCl, HBr, if you add H plus will be act as an electrophile because it is positively charged. In case of alkene, because there is carbon-carbon double bond, when bromine molecule or chlorine molecule approaches towards it, because of electron-electron repulsion, the end nearer to it carrying slightly positive charge and other end carrying negative charge. So positive charge is induced on it to make it to be an electrophile. And in this case, when bromine added to an alkene, the double bond opens, it forms this 1,2-dibromo alkene form 1,2-dibromo alkene. And in this case, one observation is that violet color of bromine is discharged. Violet color or red color, you can write red color of bromine is better to call red color. Red color of bromine is discharged. Addition reaction takes place. Red color of bromine is discharged. Discharged. It is a test for unsaturation also. One end produces plus, one end produces minus. So first bromine will attack to one end and other end will carry positive charge which will be attacked by Br minus to gives you 1,2-dibromide. Positive part approach to the double bond first, the other part carrying positive charge which attacked by negatively part. Now this reaction is not one step addition. It is not, the reaction is not one step addition. How we infer this? Suppose if we take an alkene, if we treat with Br2 and H2O, we are getting this as a product, and we get this also. Which is coming from H2O. Hence it is not a one step process. In this case, first a positive charge is produced which can attack by Br minus, which is act as a nucleophile, or H2O to gives you the product. So it is not on one step addition reaction. Now suppose I have taken this compound, it's called 2-butene. It can, because of the double bonded carbon atom, when the two CH3 group are on the same side, it is called cis. When two CH3 group on opposite side, it is called trans. When cis-2-butene treated with bromine, react with bromine, produce DL mixture. DL mixture. And trans-2-butene is very important one. I am writing it in the with a colored one also. Gives DL mixture, and trans-2-butene will gives meso. The reaction takes place through a bromonium ion intermediate. I am explaining these things to you. Suppose we have taken this. Suppose it is CH3, this is H. This is CH3, this is H. Bromine molecule approaches towards it. Because of electron-electron repulsion, this end produces plus This end will produces minus. So first a pi complex is formed over here. Now Br minus can approaches either this carbon or that carbon. This reaction takes place in anti fashion. And it is 100% stereoselective because cis gives only DL mixture and trans gives meso. I am explaining the mechanism to you, and it is 100% stereoselective. What is stereoselective means? That one particular isomer, that it is a case of space isomerism, cis gives DL mixture and trans gives meso. So in this case, if the Br attack the second carbon, let us call it as 1 and 2, if Br minus attack the second one, the product will be this. In this case, it has no plane of symmetry. If I write it this way, it will look like that. So it will be optically active. It is the case of it, and its mirror image are non-superimposable to one another, so gives you DL mixture. On the other hand, if the same reaction is carried out with trans 2-butene, the product will be as follows. This is the Br2, this is Br del plus, Br del minus. At first a pi complex is formed. The double bond doesn't break up completely, forming an intermediate like that. And Br minus has a chance to attack either the first or the second carbon, and ultimately a product will be this. Produces meso compound. Okay. Now, so what we have got, what are the important points to remember? The electrophilic addition reaction to alkene, acyclic alkene, is 100% stereoselective. Cis gives DL mixture and trans gives meso. But in some cases where is no such pi complex formation is possible, it takes place through carbocation intermediate. I will discuss these things also. In such case, we should take the case of an unsymmetrical alkene. Now, suppose, now we will explain how the rate of the reaction affected with substituent, how the rate of reaction affected with substitution. Suppose let us take a compound NO2 CH double bond CH CH3, or Cl CH double bond CH CH3, or CH3 CH double bond CH2, or CH3 CH double bond CH CH3. Note the electron density around the carbon atom. More readily it forms the pi complex, faster will be the electrophilic addition reaction. So with increasing electron density around carbon-carbon double bond. Double bond, rate of electrophilic addition reaction increases. Hence, in this case, suppose if I marked it as 1, it's 2, it's 3, it's 4. Due to the presence of 2 alkyl group, electron density is maximum in 4. So the electrophilic addition reaction will be maximum for 4, followed by 3, followed by 2, followed by 1. Because NO2 is more electron attracting compared to Cl. So in this case, electron density around the carbon-carbon double bond is minimum. Hence, the rate of electrophilic addition reaction also slowest in this case. Now, let us think of the case of an unsymmetrical alkene, such as propene, and in such case, suppose electrophile having no unshared pair of electrons, so cannot form pi bond. In this case, how the reaction takes place? Suppose if I add HBr approaches to the double bond and forming a carbocation. We know the order of stability of the carbocation are in the order 3 degree, 2 degree to 1 degree. So in this case, H plus adds around the double bond to form the most substituted carbocation. It can be this, it is 1 degree, or it can be this, it is 2 degree. So this will be the more stable. So this intermediate will be formed over here. So in this case, product will be, this will be the major product. So what is the mechanism? In this case, unsymmetrical alkene, when an electrophile attack it, it forms an carbocation with more stability. 2 degree formed, which is attacked by Br minus to gives you the product. So 2-bromopropane will be the major product, and the reverse 1-bromopropane will be the minor one, and it takes place according to Markovnikov rule. The negative part of the reagent add to the carbon atom around double bond. Having less hydrogen. This is called Markovnikov's rule. Now think of this case. In this case, both the carbon attached with one hydrogen. So in this case, how should I approach the Markovnikov's rule? In this case, I should think of which carbocation is more stable. It can be from this. If H plus attack over here, positive charge will be formed over here, or it can be this also. It's 1, it's 2. It is only 2 degree, and it is 2 degree with more resonance stabilized, because phenyl group is over there. In this case, it is resonance stabilized because the pi electron comes into resonance with the positive charge, makes it more stable. So the desired product in this reaction will be pH, phenyl group CHBr, CH2, CH3. This is case 2, where no such pi complex is formed and carbocation formation is the choice over here. Now think of the another one. Let us think of this way. Cl. If we add HBr, in this case also there is two possibility of forming carbocation, either this one or the unshared pair of electron comes into resonance, makes it stabilized. So in this case this will be the more stable, and Br minus will attack over here, so gives you this as the major product. CHBr and Cl. So 1 bromo 1 chloroethane will be the major product over here, not the other one. Now we don't consider the case of fluorine, addition of fluorine to carbon-carbon double bond, because fluorine is highly reactive and the carbon-carbon bond may rupture. So you don't consider the case of your bromine over here. Now think of another reaction. In this case, all of them are the case of electrophilic addition reaction around carbon-carbon double bond. Now, if I take the case of this CH3, CCH3, CH3, CH double bonded CH2. It's an interesting case where the carbocation formation is formed followed by rearrangement to form more stable carbocation, to form more stable product. Suppose HBr is added over here, H plus will attack it, where this carbocation is formed because it is 2 degree more stable compared to the positive charge on the terminal carbon. It is 2 degree. If methyl shift takes place, that is called 1,2 shift. In this case, what happens? It is only 2 degree, but after methyl shift 3 degree carbocation is formed, it is more stable. In this case, Br minus is there, attack over here, so this will be the major product. Okay, now these are all acyclic compound. In case of open chain compound, in case of closed chain compound, I will discuss one to such cases. Look at here. Actually, it is the case of your CH and double bonded CH2. Actually, I am writing it again for you because the handwriting, you won't follow it because the writing is a bit blurred over here. So think of the case of this. It is cyclopentyl ethene because carbon-carbon double bond will be the part of main chain. If we add HBr, this will be formed plus, and it is the case of your CH3. Actually it was CH double bond CH2. It was CH plus CH3. Now expansion of ring takes place over here. This positive charge comes over here. As the bond moves from here to here, so this particular carbon will carry positive charge, as you see. And Br minus will attack over here. So this will be your product. What will be the product? One, 2, 3, 4, 5, 6. 6 Br over here. So bromo cyclohexane will be the product over here. Or if you don't follow it that much, Br minus attack over here. So it's the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. So cyclohexane ring with bromine, so it's called bromocyclohexane. These are all the part of your one double bond is there. In case of diene, mostly you should consider the case of conjugated diene like that. In this case, there is two possibilities. Suppose there is a chance of 1,2 addition as well as 1,4 addition. One-4 addition is thermodynamically controlled product. And 1,2 kinetically controlled. One-4 addition product is more stable. Now, how the addition takes place with HBr or with Br2? Anyway, you can do. You can write anything you like. First, it will form this. Br minus can attack over here, or due to resonance, there is one more structure. If Br minus attack over here, it will be the case of 2 bromo. In this case, if Br minus comes over here, in this case 1, 2, 3, 4, 3 bromo butene of, or Br minus if comes over here, what it will be? In this case, it is bromobutene, bromo 2, 1 bromo 2 butene. Okay. In this case, what it will be? 3 bromo butene. These are the two products, and 1,4 addition is more likely than 1,2 addition. So the major product should be CH2Br, CH double bond CH, CH3. This will be the major product, which is formed by 1,4 addition, because it is the first carbon, it is the second, it is the first, it is the second, third, fourth addition takes place. H and Br addition takes place around the first and the fourth carbon, and double bond is shifted to second and third, which is happen over here. This is a major one, and it is a minor one. Minor one will be what? CH2Br. Minor one should be CH2 double bond CH, CHBr, CH3. This is the minor, other one is the major. Let us up to this. Hope you will follow it. If any problem, you can contact me on my WhatsApp number, which will be given over in the description box.